everyone, and welcome to Gravity Time. I'm an astronomer from the Gravity Time team, and today we're exploring one of the most extraordinary space events of our time, something so rare, it barely fits into our understanding of the solar system. This year's biggest astronomical headline isn't a star or a planet or even a black hole. It's an outsider, a wanderer, a visitor from another star system. Its name is 3I, Atlas. Some scientists whisper a bold question. Could it be artificial? This isn't just another comet or asteroid. Atlas is what astronomers classify as an interstellar object. Something born in another planetary system traveling across the galaxy that has somehow drifted into ours. This has happened only 3 times in recorded history. First was Oumuamua in 2017. Cigar-shaped, fast-moving, and utterly baffling. Second was Comet Borisov in 2019. Much more typical, icy, and comet-like. And now, the third one, 3I Atlas, discovered this year. We've talked about interstellar visitors before, but this time, new data is pouring in. Telescopes worldwide are locked onto this object, trying to answer the same question. What exactly is it? From every corner of the planet, observatories are tracking Atlas, measuring its speed, analyzing its tail, studying its orbit, scanning for heat, radio signals, or anything that hints at its origin. This episode is dedicated to everything we've learned and everything we still don't understand about this cosmic intruder. If you're fascinated by the idea of something entering our solar system from another star, settle in. This may be one of the most important stories in modern astronomy. Let's pause on one fact. Until 2017, we had never seen an interstellar object pass through our solar system. And now, within just 6 years, we've detected 3 of them. Are they rare? Or have we only just begun to notice them? Think about it. For most of human history, our technology wasn't capable of detecting small, fast-moving objects beyond Neptune. Only recently have sky survey telescopes become powerful enough to scan entire swaths of sky every night, which raises a thrilling possibility. Has the galaxy been sending visitors all along, and we're only now learning to see them? Atlas is headed straight through the inner solar system. Once reconstructed, Atlas's path revealed a journey that seems almost too perfect. October 3rd, 2025. It will sweep past Mars, around 019 AU away. November 3rd, 2025. It will pass Venus. December 19th, 2025. It reaches its closest approach to Earth. March 16th, 2026. It flies dangerously near Comet, Jupiter, Arctic. But there's a catch. The Earth encounter is behind the Sun. It will hide from our ground-based observatories at the very moment we want to see it most, almost as if it chose that route. Our only eyes, solar observatories. Because Atlas will be hidden behind the Sun, only spacecraft capable of blocking out solar glare will be able to study it up close. SOHO, the Solar and Heliospheric Observatory. STO, Solar Dynamics Observatory. Both have coronagraphs, instruments that create artificial eclipses, allowing us to see objects near the sun's edge. If we're lucky, these solar sentinels will capture Atlas as it slips silently behind our star. Up to this point, Atlas behaved like a classic interstellar traveler. Fast, mysterious, hard to observe. But then it did something truly unexpected. It started evaporating, far earlier and farther out than any normal comet should. Typically, comets only begin to wake up when they cross inside Jupiter's orbit. Closer to the sun, the ice on their surface heats, vaporizes, and forms a glowing coma and tail. But Atlas, it began outgassing well before reaching the region where solar heat could affect it. That means it contained material so volatile, it sublimated even in the frozen outer solar system. Astronomers measured this evaporation using hydroxyl detection, a byproduct formed when sunlight breaks apart water molecules. The result? Atlas is losing nearly 40 kilograms of water per second. That's 4 large buckets per second, at a distance where most comets remain silent and frozen. The Spherex infrared telescope made another discovery. Atlas is venting carbon dioxide, also known as dry ice, in unusually large quantities. Most comets contain far less CO2 than water, yet Atlas appears to be rich in it, forming a temporary dense atmosphere, the classic cometary coma long before it should. This early activity raises questions. Is Atlas made of exotic ices not seen in normal solar system comets? Is it older, colder, or chemically different, shaped in another star's nursery? Or was it constructed to survive interstellar travel? There's a frustrating fact about interstellar visitors. They move too fast for us to build missions to meet them. A spacecraft takes years to design and launch, while Atlas will pass through in months. By the time we knew what it was already on its way out. While we can't launch something new, we can redirect instruments already in space. Two missions are fortuitously positioned to observe Atlas up close. NASA's Psyche is currently en route to a metal asteroid and is equipped with high-quality cameras. Its path may bring it near Atlas. ESA's JUICE is heading to Jupiter's moons and carries powerful spectrometers, which could analyze Atlas in infrared and UV bands. Is Atlas just an exotic comet or something built and sent? Not every interstellar visitor raises eyebrows. Comet Borisov behaved like a typical comet, icy and predictable. But Oumuamua in 2017 and now Atlas don't follow the rules. They provoke a daring question, the kind scientists rarely ask out loud. What if these are not just rocks? What if some of them were sent? Oumuamua stunned astronomers for three reasons. First, its shape was long and thin, like a cigar or a flattened shard, over 8 times longer than it was wide. Second, after it passed the sun, it accelerated, not from gravity, but with no visible gas jets to explain it. Finally, it tumbled irregularly, almost like a loosened panel or sail. Some speculated it might be a light sail, a thin reflective object propelled by starlight. Harvard astrophysicist Avi Loeb published the idea that Oumuamua could be artificial, a fragment of alien technology. Many dismissed it, but no one could fully explain its behavior. Now Atlas shows its own oddities. Atlas doesn't appear as elongated as Oumuamua, from what little we see, but it has its own list of strange behaviors. Suffer. It was entered the solar system on the exact plane of the planets. It will pass near BDF, Mars, Venus, and Jupiter, but Shitsi avoids Earth. It hides behind the sun during its closest approach to us. If this were a reconnaissance probe, its trajectory is strangely efficient. Coincidence? Possibly? Deliberate? We simply don't know. Criteria for something artificial. A team of young astronomers recently proposed 5 indicators that an interstellar object might be technological, not natural. Clue. What it means. 1 shape, non-natural geometry, cigar, disk, sail. 2 motion, acceleration without visible outgassing. 3 surface spectrum, metallic or manufactured materials. 4 infrared emission, internal heat sources, engines. 5 narrowband signals, radio or laser emissions. Atlas has already triggered questions on motion and evaporation, and the other 3 remain under investigation. Shakatur, we've been fooled before, by ourselves. Astronomy has a history of mistaking human-made objects for asteroids. Soviet Venus probes rediscovered decades later. Apollo rocket stages drifting back into Earth orbit. Forgotten spacecraft mistaken for new asteroids. But in all those cases, they were ours. The day we find something built by someone else, that will be the greatest discovery in human history. And that is why Atlas matters. Whether it is ice or intelligence, comet or construct, it has traveled across the galaxy to reach us. Interstellar visitors like Oumuamua, Borisov, and now Atlas are more than scientific curiosities. They are messages, not written in language, but in motion, chemistry, and origin. They remind us that the solar system is not isolated. We are part of a much larger galactic ecosystem. Centuries ago, when meteorites fell to Earth, people called them gifts from the sky. Long before rockets, before telescopes, before spaceflight, the universe sent us samples for free. We studied those fragments and learned that planets can form iron cores, asteroids carry water, and the solar system is full of carbon-based material. The seeds of life. But now the stakes are higher. These interstellar objects are not pieces of our own solar system. They were formed around other stars, under other suns, orbiting worlds we may never see. What they carry includes unfamiliar ices, exotic chemistry, and maybe even engineered material. We don't need to travel to alien solar systems yet. Their messengers are coming to us. There's a cruel irony to the situation. We finally detect these visitors, but they are moving too fast to reach. Before we react, they are gone. Atlas is racing out of the solar system even as we speak. By the time our technology catches up, it will be light years away. We can only observe and wonder. A time will come when we'll have rapid response missions. Spacecraft waiting with fuel, ready to launch the moment an interstellar visitor appears. We will chase it down, photograph it closely, drill into its core, and return fragments to Earth. The day humanity captures an interstellar object, everything will change. If one of these objects, Atlas, Oumuamua, or some future traveler, turns out to be artificial, it will not simply be a discovery. It will be a conversation, a confirmation that someone else sent a message, even if it was launched millions of years ago. That would mean we were never alone. We were simply not looking carefully enough. This was the story of 3i Atlas, an object older than our planet, crossing our path for just a moment. Whether it is ice, stone, or starborn technology, it carries a truth from beyond our sun, and we are lucky enough to witness it. Thank you for watching Gravity Time. If you want to keep exploring the mysteries of the universe with us, stay curious and keep